Hello everyone, welcome to Code and Learn. This is another data structure and algorithm video. In this video, we are going to talk about sorting. This will be a theoretical video. We will cover sorting, the purpose of sorting, the key characteristics that we look at for sorting algorithms, then go over the common sorting algorithms, followed by different algorithms or different types of algorithm. So let's get started. Sorting algorithms are the fundamental tool in computer science. Why do we need sorting? It is because we usually need to sort or arrange elements of a list or array in a specific order. We've already seen how an ordered array can improve the efficiency of our algorithms in certain cases. Organizing data, as we saw with ordered array, helps with efficient searching, retrieval, and processing of data. So these can be thought of three major reasons why we need to organize or sort the data. Next, let us look at the key characteristics of any sorting algorithm. So whenever we are developing a sorting algorithm or algorithm in general, the first thing we look at is the time complexity. That is, measure the algorithm's efficiency in terms of time, which is, as we learned earlier, is expressed as O notation, like O of n. Usually the best sorting algorithms will have a time complexity of O n log n. Then we look at the space complexity, which is how much extra memory the algorithm is taking to complete the sort. Some algorithms do the sorting in place, which means no extra memory is used, which is we get a space complexity of O of 1. The third parameter that you usually look at when looking at sorting algorithm is the stability of the sort. A stable sort, for example, will maintain the relative order of elements with the equal keys. Generally speaking, there are two kinds of algorithms. The first one is the comparison based. Some examples are quicksort, merge sort, bubble sort, selection sort, etc. In comparison based algorithms, the algorithm compares the elements to sort them into place or to move the elements into their correct positions. Then there are non-comparison based sorting solutions or algorithms. These rely on other techniques to sort the data in the list or array. Some examples are counting sort, radix sort, and bucket sort. We will look at all these algorithms. Bubble sort is the most basic sorting algorithm. In bubble sort, you perform repeated steps through the list comparing adjacent elements and swapping them if they are in wrong order. It is really simple to implement but is inefficient for large data set. Then we have the insertion sort. In insertion sort, you are basically picking up one element at a time and then inserting it in the correct position according to the sort order. So it basically builds the final sorted array one item at a time. It is really efficient for small data set or nearly sorted data, like for example a 10 element array where only 2 elements are out of place. Then we have selection sort. In selection sort, we repeatedly find the minimum element from the unsorted part and place it at the beginning. We repeat these steps multiple times. It is simple but generally less efficient than insertion sort. Then we have merge sort. In merge sort, you divide the list into two sublists and then sort them recursively and merge them together to end up with a sorted list. Merge sort is efficient and stable with a time complexity of O n log n, which is one of the quicker time complexities. Then we have quicksort. In quicksort, you would select a pivot element and partition the other elements in two subarrays according to whether they are less than or greater than the pivot. It is generally very efficient with an average time complexity same as that of merge sort, which is O n log n. Then we have the heap sort. Heap sort uses a heap data structure to sort the elements. It is efficient with the time complexity of O n log n. So these three algorithms, that is the merge sort, quicksort, and heap sort, have a time complexity of n log n. They have other trade-offs that we will look at when we look at these algorithms in detail. In the non-comparison based sorts, we first have the counting sort. In counting sort, the algorithm works by counting the number of occurrences of each distinct element. It is efficient for sorting integers within a specific range. Then we have the radix sort, which sorts elements by processing individual digits or characters. It is efficient for sorting integers and strings. Then we have the bucket sort, which distributes the element of an array into number of buckets. Each bucket is then sorted individually, either using a different sorting algorithm or by recursively applying the bucket sorting algorithm. So these are some of the major sorting algorithms. The choice of sorting algorithm depends on factors such as the size of data set that you are sorting, the type of data, and the required efficiency. You will see that many programming languages provide built-in sorting functions that are optimized for performance. So most of the time you don't really have to implement sorting algorithms, but it is always good to understand how sorting works if you are going to decide between different sorting algorithms to use. So that's it for this lesson. I hope you enjoyed it. If you have any questions, please post a comment under the video or reach out to our Discord server. Until next time, happy coding!